Assalamu alaikum, dear students. Bismillahir Rahmanir Rahim. This is lecture number 8 and 24th April. In this lecture, I will be covering practice problem 8.2, and I will just again tell you that I have made this number of my cell phone available for WhatsApp and for your audio queries. So I will just again say that I will prefer that you send me your all the queries on our 4A group, ENA group. But if any one of you is not on the group, please make sure that you join that group as soon as possible. But until then, until you have not joined the group, so this number is available. You can just call me, or you can just preferably WhatsApp an audio message for your query. And it will be a very small lecture today, and in this lecture I will be just telling you about the solution of the 8.2. So this is practice problem 8.2. We will be doing a lot of practice in this chapter. This is a very detailed chapter and a very important one from understanding point of view, the RLC circuit. And I just again tell you that these are not the kind of the lectures which you can just watch, sit back and watch and you understand the topic. These are not made in that way, and these have not been recorded in that way, that I just sit back and just start speaking something and then you just get that what I am saying and what I am explaining. It's not like that. It's not going to work like that. You actually have to sit very firm, very straight, very focused, and you will have to watch this video several times before you can just understand the topics being discussed in this video. So okay, where I just want to know that I am just still in recording mode. Yes, I am in recording mode. Thanks God. Right. So this is a kind of lecture videos in which I am just explaining the things, but these are the problems for you to practice. So you start, you pick up your pen, and before watching the video, you just try to solve these problems on your own. And if you find any problem, or if you don't get the right results, or you don't know how to proceed from some point, and you don't have any idea of how to get get on from this point, then how to proceed, then you can just refer these videos. So this is the way that you should be consulting these videos if you just really want to get the real practice of this subject. This is not a kind of thing which is very easy. It needs a lot of involvement from your side, and a lot of focus and a lot of practice. So for grasping these concepts, these practice is means unavoidable. You just cannot just learn anything without a practice. Even just a single practice is not enough. You will have to solve number of problems. So I will be spending next 4 to 5 6 lectures on this. Let's see how I just go. So this is the problem what they are asking. Before that I start my problem and lecture, I will just like to say ayah from Quran Kareem. Allah subhanahu wa ta'ala says, Auzubillahi minash shaitanir rajim, kullu mata'ud dunya qalil. तो सारी की सारी दुनिया का जो मता है, ख़ज़ाना है, अल्लाह उसको फरमा रहे हैं बहुत थोड़ा है. और एक जगह अल्लाह ताला ने फरमाया कि जो अल्लाह के अलावा जिसको पुकारा जाता है उनके हाथ में कितमीर भी नहीं है. और कितमीर से मुराद वो क्या है? कितमीर का मतलब है कि खजूर के अंदर गुठली के अंदर वो सफ़ेद झिल्ली गुठली के ऊपर, उसको कुरान में कितमीर के नाम से बयान फरमाया है. तो जिनको अल्लाह के सिवा पुकारा जाता है उनके हाथ में कितमीर भी नहीं. और फिर अल्लाह ने फरमाया कि जो पुकारते हैं और जिनको पुकारा जाता है अल्लाह के सिवा, वो दोनों ही ज़ईफ़ हैं. ज़ऊफ़ तालिब वल मतलूब, दोनों ही ज़ईफ़ हैं. तो भाई हम जो है ना अपने अंदर अल्लाह की बड़ाई को पैदा करें और आखिरत का शौक़ पैदा करें और अपने ईमान की फ़िक्र करें. ईमान तो अल्लाह ने माँ की गोद में दिया है, लेकिन इसको बनाना है तो इसकी फ़िक्र करें. तो अल्लाह ताला कहने सुनने के साथ अमल की तौफ़ीक़ अता फ़रमाए. So this is lecture practice problem 8.2. What they are asking, they just want to ask about the initial conditions, that we will be just finding the initial conditions from this numerical, and how we will be going from this for finding this initial condition, because this is UFT and UFT is only one after t is equal to 0. So that means this supply is being connected at t is equal to 0. Before t is equal to 0, the supply is just not there. So we will just make the circuit of t less than 0, and then we will be finding the values of this IL. This is where is IL? This is IL, and this is VC, and this is the voltage across the resistor VR, right? And then we have to also find out the derivatives of all these things, and then we have to also find out the steady state values of these same variables VC, IL and VR. So I will just show you the solution here. So this is the solution. I will just zoom it for you. Okay, this will be quite helpful. This zoom level will be quite helpful for those who are watching these videos on mobile phones, because the screen is very small there. So this level of zoom is really required. For PC users, they can just work with, they can go with smaller levels of zooms. So this is problem number 8.2, and this is the circuit. I have drawn it just like this as it was in the book. And for circuit for t less than 0, this 4 multiplied by UFT, it's a current source, has been eliminated, and whenever you have to eliminate a current source, you just open circuit it. So this has not been drawn. And for a capacitor, it is open circuit for a stable state, and a inductor is a short circuit for a stable state. Other than this, all these things are same. So we have to find out what is going to be the value of this IL. IL is very visible, that it is short circuiting a current source. Current source will just make sure that this 6 ampere is going to pass through this. Here is this point, and because it will find a short circuit here, the path of a shortest smallest resistance, so all the current will just pass through it, and this IL is in the downward position, and this 6 ampere is going upward position. That's why I have just written this inductor current IL is equal to minus 6A. And because there is no other supply other than this current supply, and this current supply is already shorted, so there is not going to be any voltage on the VC or VR, right? So VC is going to be equal to VR from the connection point of view, because you see that plus terminal of this VR and the plus terminal of VC is same. And if you just go all the way from this minus terminal to this, all the way to the minus terminal of the VR, you will say these are in parallel. So when the voltages are in parallel, they are same, right? So this was the circuit for t less than 0. Now we will be drawing circuit for t greater than 0. When we draw t greater than 0, what will happen is that this 4 ampere current supply will come in action, and it will be connected to the circuit, and this supply will remain there as it is for all the time. So now we have to find out the values of different variables from this. So what we will be doing is, as mentioned here, we will be applying KVL on the middle loop. So this is the middle loop here, just I am showing with the mouse. So this is the middle loop. So what will be the voltage of this KVL? How we will be going to apply KVL? This minus sign comes here, minus VC, and then we come to VR. So this is VR plus VR, and this is VL. So VL is given by L di by dt. If the current is going into the terminal of positive terminal, we will write it plus, and if it is going into the minus terminal, that means we will be writing it as minus. So right now it is plus VL, and plus VL means L di by dt is equal to 0. This completes the loop, and putting the values, because we already have found the initial conditions of VC bracket 0 and VR plus 0. So putting value of these things, this is 0, this is 0. The only part that remains is L di by dt is equal to 0. Right. Scrolling up for next steps, what I will be doing is applying KCL on node B. So what is node B? Node B is this one. I just again show you where I have just mentioned node B. I can show you here. Wait for a second. You see that this is node B and this is node A. But because this diagram is adjacent to the topic being discussed, we will just refer this diagram directly. The only difference is that this is for UET, otherwise this is 4 amperes after time t greater than 0. Alright, so applying KCL on node B. So what was the node B? Node B is this one, and what currents are going from this? The current of IR is coming towards the node, so it will be taken positive, and the magnitude of this is VR up divided by 5. Inductor current is going down, and it is going away from the node, and this is also going away from the node, a power source, a current source of 6 amperes. So we can just find out the derivative of VR from here. So it is 1 upon 5 derivative of VR, and derivative of IL is equal to 0. So dVR is going to be 0, because we already have found this thing in the upper step, derivative of the inductor current, so we can just put in 0 here. So if we just put a 0 here, so this is 0, this is 0, this equal to 0, 5 multiplied by 0 is 0, so this derivative of VR is also 0. Then applying KCL on node A. Okay, sorry, this should be node A, not node B. This is node A. And where is node A? I will just show you where is node A. Node A is this one. So I beg your pardon, this I have just mistake by mistake. This I have written as node B. So accept my apologies for it, and correct it. I will just again tell you that you must have the book available in the form of PDF here with you, so that you can see what is being discussed and what are the contents of that book, contents of the can be topics which are being discussed here. And you should also have your pen and pencil and the calculator available for solving all these numericals on your own. Right, so a 4 ampere current is going towards the node plus this is IC, and IC is given by C dV by dt, and IC is taken as negative because it is going away from the node, and this is going away from the node as well. So that is this thing, that is VR upon 5. Right, so applying the initial conditions and giving the value of VR initial condition, so this can be just found out by calculation, and this comes out to be the derivative of the voltage of the capacitor. Circuit for t greater than infinite, it means this is the circuit when everything has stabilized. So this capacitor becomes open circuit and the inductor becomes short circuit, and then finding out the values of applying KCL on node B. This is node B, so this 4 ampere is on node, applying on node B. Node B, yes, this is node B, yes, this I have written it correctly here. So 4 ampere is coming from here because this is an open circuit, no current amount of current is going to pass through this capacitor in stable mode, because capacitor would have been completely charged and it will function as open circuit. So 4 ampere is coming from here, IL is going down, and the -6 is also going down. So we just found out IL is equal to -2. Alright, we just found it out by the calculation. IL is equal to this, and VC, because there is no power supply connected, this is open circuit here. So in a stable condition, what will be going to be happen, because this whole current is going to pass through this. So the whole current is going to pass through this 4 sorry, what I'm saying, I beg your pardon, this 4 ampere is going to pass through this VR, so this will become VR is equal to 5 multiplied by 4 ampere, that is 20, and these terminals are common, so VC is also going to be 20. VC is also going to be 20, the stable voltages. So I hope this was helpful for you, and next I will be just solving few numericals from the end of the chapter, and I will also be extending the date for your assignment submission, and assignment submission is much more important than normally we have, because in normal we assign normal mode. In conventional classrooms we do have some other methods of assessments also, but in this mode of teaching, that is online teaching, there is a very less margin for assessment. So please be very regular in your assignments and practice and submit it on time. So till then, fi amanillah. Assalamu alaikum.